communicate a pretty new idea of LaRouche's. He's quite the endless wellspring of new ideas. So he's definitely trying to provoke something around metaphor and language and communication. So LaRouche is saying we're going to have to learn to communicate with the universe. And right now, our modes of communication, especially in human society, tends to be what? Talking, right? Language. Which is not unimportant. That's very important. So you have speaking, and written language, and what else? When someone talks about communication, what? Images? Yeah. Right, a picture's worth 1,000 words. I think we should reject texting as a mode of communication. And then, there's music. I have a fun example. So this, that's a killer whale, an orca whale, attempting to communicate by imitating a motor boat. Okay. Yeah, I'll repeat. That was just an orca whale, not Mitt Romney. This probably communicates a lot. And that probably communicates a lot. I think this is a really good example of metaphor. Because this never happened literally, to have all these scientific and philosophical minds from different times in history all being in this really nice room. That didn't really happen literally. But that's the point about with language and communication. I think a lot of people here just sort of agree that it's not a literal activity that you're trying to do. I mean, sometimes, okay, the coffee costs $2, and you pay the person $2. You're communicating, and it's very literal. But for the really important stuff, most people here probably agree, right, that it's not something simple or literal that human beings are really attempting to do, especially like more profound ideas and emotions and stuff like that. But what's wrong so far, what's limited about all of these types of communication with the artwork, poetry, all that stuff, everything we've sort of touched on so far, is that it depends on sense perception, right? Eyes and mouths and ears. But this is what LaRouche is thinking about. This is his latest paper, The Mystery of Your Time. We'll just read it. It's not that long. which he calls, this is the chapter 3 on Kepler and metaphor. The principal challenge which I present to you in this chapter of the report at this time of world crisis is the necessity of freeing mankind both individually and in broader terms of reference from the present, inherently terrifying crisis threatening our society now and in the estimated not too very distant future, by our means of the aid from a set of new substitutes for today's conventional notion of language. A chance which we must, in the process of developing for the practical purposes of thinking about mankind's nearby future, as it is to be considered within our own galaxy, the galaxy of which our solar system is only a relatively tiny part. So this is something we've been talking about for a long time, right? These extinction cycles, just this threat, severe weather, all this stuff. So Lynn is saying that to really get at figuring this stuff out and solving these problems, one of the major barriers to getting there is language. So we're going to have to overcome that. He says, the importance of that matter of language, which pertains to the most urgent requirements in the here and now, will not be so much the language required to enable us to communicate with one another person socially, but rather the radically new quality which must be incorporated within a more advanced form of the kind of language which our minds must acquire for the purpose of thinking in terms of sufficient, actually scientific relevance for mankind's dealings with physical processes on the scale, in the types, and according to broadened definitions of extended forms of human actions among our local galaxy and its neighbors. So he's saying to do that, to develop that new type of language skill, is going to come from metaphor. And I think using Kepler as the example of that is useful, since most of the former LaRouche youth movement worked through Kepler, so that's kind of nice. He's using an example we actually did a lot of work on. But because what his discovery, it was made without the use of any direct sense perception. And Kepler knew that was going to be necessary. He couldn't make the discovery in any other way. You couldn't do it with sense perception. Because what you're trying to figure out is an unseen, unseeable physical principle, an ordering principle or causal principle. In his case, right, looking at the ordering of the solar system, that whatever is organizing it and guiding its development is not going to be sense perceivable. So what you end up doing is pushing your sense perceptions to their limits, finding paradoxes, and then making an actual discovery into the realm of that which cannot be perceived. And just to make that point, just to really re-emphasize it, because for example, the Earth's magnetic field, we, human beings, our eyes, we don't see it. But birds do. So again, we're not talking about things that we don't see, or we don't see yet, because now human beings, we've developed different types of telescopes and various instruments and apparatus to perceive a lot of things that before we couldn't perceive, and that's what we talk about with our extended sensorium. But We're actually trying to get at things whose very nature, it's not a matter of us not being able to see it yet, or like developing a new instrument to perceive it, but its very nature is that it cannot be, it has no material substance or existence, has no material existence, but that is the substance of the universe. So we're going to have to figure it out and get at it somehow. So first, what Kepler did, the first step of figuring out something new is, because a lot of things, Kepler definitely was not the first to discover that there are planets, right? Those were discovered a long time ago. And there were lots of opinions about those things. And there was a very established, scientific opinion about those things. So he had to discover what's really going on with these things. So the first thing he's got to do is knock down this scientific priesthood, and the basic fundamental assumptions, which were that the planets are in circles, the planetary paths are circles, and that there's uniform motion. But since the circles didn't quite work out with uniform motion, because you can observe that the planets speed up and slow down, people way back when invented this thing called the equant. So it was a point, not the center of an orbit. So you can all see that's a perfect circle, and that's the center. But as the planet's moving around, it's not quite moving around perfectly. So they said there's this other little point around which the measurement of the planet is equal. So those are the assumptions. Obviously, they are based on sense perception, because people are saying when you go out and you look at the stars, they go like that. So that must be what's really going on, because that's what I see. And then they come up with models to explain what they see. And then there's a bunch of other oligarchically imposed religious views about perfection and why it would have to be a circle and all that kind of stuff. So Kepler's first job is to overthrow the old system. And he uses paradoxes, and he's way more rigorous than anybody else. Because you take the dominant system at the time, at Kepler's time, was Ptolemy. And so Ptolemy assumed that the orbit of the planets are circles. Now, in geometry, to make a circle, all you need are 3 points. And any 3 points, not in a straight line, will define a unique circle. So if you're trying to figure out Mars's orbit, and you think it's a circle, you just go out, find 3 different observations from Mars, and bam, you've got its orbit. Easy. So Kepler did not allow that much assumptions. He got a different, an extra, a 4th observation, found the circle, then found the center. He didn't just assume. So he does all this very rigorous, very lengthy, a lot of work to find the actual orbit. And he does it. But from the standpoint of longitude, like looking at the planets about how they go this way, relative to this other astronomical term called the ecliptic. That's okay. So he's figuring out how you can observe the planet, and he's very accurate this way. But not all the planets lie on an exact plane. They're all also a little inclined up and down. So once he gets everything worked out perfectly this way, through all the most, like the best observations, the most rigorous geometry. Like it's perfect, unarguably. But now he looks at them this way. So then he takes into account their latitude, and he gets a different orbit. But everything he did, the same quality of the most accurate observations, the least assumptions, the most, rigorous geometry, and he gets a different orbit, a different equant, however you want to put it. So, he did everything right, and it's coming out wrong. So, he says, therefore, the observations were right, my method was right, the thing that must be wrong are the basic assumptions, right, of this circle and the equant. They can't exist. I've just proven them absurd. So then he goes on to discover what they really are, right, which is ellipses. And I know I'm giving away the answer, right? They're ellipses. He figures it out. But he's still provoked, because what led him to this discussion from the very beginning is he had a hypothesis as a young man that human beings are unique creatures and we can come to understand God's creation. And there's observably, how many planets did they have? Mercury, Venus, Earth, Mars, Jupiter, Saturn. So they knew of 6 planets. And his question was, well, why 6? And why are they where they are? So he goes through lots of different ideas throughout his career. First he has this idea about geometry of platonic solids, but then they're not circles. So now he's with the ellipse question. And then, so now he's still thinking, well, why those ellipses? And what an ellipse is, because this was also a big thing at the time, the supposed debate, like the difference between Republicans and Democrats today, was the difference between the heliocentric and geocentric system. And at the time, more or less, you had Copernicus just switch the Earth and the Sun. They didn't really actually change anything. So whether the Sun was at the center or the Earth was at the center, because everything was being based on your sense, perception, observations, from your standpoint, everything was around that. It didn't, whether it was Sun or Earth at the center, it didn't make a difference. But with the ellipses, right, that's two, rather than having the circle has one center, an ellipse has 2 foci around which the ellipse is constructed. And that the Sun, for all of the ellipses, the Sun, right, was one of the foci of every planet's orbit. So he really figured out it's really a heliocentric solar system. But why of the infinite number, why that one? Or why those ellipses? And so then his next major work, right, was the harmonies of the world. So obviously his hypothesis is a musical one. Well, and here's what Kepler thinks about harmonies. This is in book 4, right before he gets to where he gives you the answer of where the harmonies are. He's discussing, well, what is harmony? And he states very explicitly, it's not a sound. Even a musical harmony is not a sound. He says it's easy to understand that the nature of harmony is not to be defined by means of sensible things alone. like sound or light. For a sound is one thing, a definite order among different sounds is another. Therefore, there can be different sounds, but unless there's a definite order among them, which is defined by definite proportions as a matter of mathematics, there will be no harmony among the parts. So this being a matter of ordering, you're in the realm of relationships. And then the other thing he says is that in order to perceive a harmony, not just a sound, but a harmony, to recognize a relationship, a soul is required. And he says, in general, every relation is nothing without mind, apart from the thing which it relates, because they do not have the relation which they are said to have unless the presence of some mind is assumed to relate one to another. So what he ends up finding is that the musical harmonies that you hear, musical melodic tones, can be given mathematical ratios. So in the planetary orbits, he's looking to find where these mathematical ratios can be found, these harmonic proportions. And he ends up finding them in I know I'm giving away the answer again, in the extreme motions of the planets. So each orbit, so here's the sun. When a planet is closest to the sun, when the blue planet is closest to the sun, that's called perihelion. And the furthest from the sun is called aphelion. So one thing that Kepler does, right, is one of the first hypotheses that he has is that the harmonies would be just per orbit. That one planet amongst itself would somehow generate these proportions, and some of that kind of works. But then in principle, he knows that couldn't be it because it is a whole system. One planet just has its own self-contained harmony, and it's not really part of an entire system. So it's right, on principle, that he finds that the harmonies exist in the motions, the extreme motions of neighboring planets, the way they work together. So for example, we'll just make it really simple, right? Here's another orbit. It'll just have to be a black planet. So here's this planet's perihelion and aphelion. So the converging motion is the aphelion of the inferior planet relating to the perihelion of the superior planet. So the aphelion of inferior planet relative to the perihelion of the superior planet. And then the diverging motion is just the opposite. So they have to work together at their extreme, the slowest, because when you're, this is another key, because then this is what would say where the orbits would have to be, because if you need this planet's motion at helium, you're furthest from the sun, so what does that mean about your motion?
Slower.
You're slower. So you need that to match up with this planet's perihelion. When he's closer to the sun, you're faster. So in order to make the harmonies work, like, the sun's got to tell Saturn, like, scooch out a little. Like, oh, Jupiter, come in a little. And that's a really fun idea. I think it's really, and Kepler has the sun go through a certain decision-making process at the end of book 5, and he kind of tunes his chorus, or tunes his orchestra. And he's got to get everyone a little just right. But that's kind of weird, because the sun doesn't have ears or eyes, yet it's organizing the entire system of planets and their motions according to the principles of musical harmony.
Can you go back a little bit and help me understand where he got first the idea to look at it from a musical perspective? As you said, sort of like from a young age, he had this idea that these are reasons that we can use, and that every real discovery of universal principle won't be based on sense perception.
Yeah.
So, but what led him to look at music and platonic songs?
Yeah. Well, because I think harmony is an idea. Harmony would be a principle. And music is a metaphor for harmony. And geometry is a metaphor for harmony. That music is a metaphor in the audible range, and geometry is a metaphor for harmony in the visual range. And what you're trying to get at is that idea of a harmonic principle governing an entire, process in the universe. So, yeah, these are metaphors of ways to get at what this thing could be. Generally, also, the separation between art and science used to not exist. Aristotle and Ptolemy and these guys, especially the Aristotelians, they were fighting to create this separation. But like in the Pythagoreans and the Platonists, they didn't have that problem at all. So there are very old ideas about music and astronomy, geometry, because it's one universe. There's just different aspects of it that the human mind is trying to discover. And it's very clear that the Platonists, Pythagoreans, a lot of their stuff was destroyed, so I don't really know that much about them explicitly, but the Platonic school is so explicit about how the mind is out to discover things that are beyond sense perception, that the real universe is not what you perceive at all. It's the unseen that's real. And the Christians took this up, and Cusa really revived this with the Italian Renaissance. Like what Brunelleschi did in building the cathedral at Florence, using an unseen principle, the catenary. and gravity and force and all these things that you would use to construct a building, they're not, those are physical principles that you don't see. You can discover them, certainly, but you don't see them. So, I think in a certain school, which Kepler explicitly adhered to, he totally rejected the Aristotelian school of thought and totally promoted Cusa and the Platonic school. So in his mind, these aren't really separate issues or something like that, but they're ways to go about discovering the real unseen universe. That's, yeah. And so Cusa is very explicit about the quality of the human mind. The quality of the universe must be the same. They're of the same quality. Otherwise, it wouldn't be open to discovery by the human mind. And so Kepler, it seems very provocative, but that's his idea, also what's going on with the sun. Because he goes through this whole discussion about how in order for there to be a harmony, a mind must be present. And he's just shown that the solar system is organized. You can find where harmony has organized the whole solar system. There's a mind somewhere. And he also says that about each planet in the New Astronomy. There's this one part, it's in chapter 39, and so he's gone through all this geometry, he's figuring out what the planets are, and then he's going through how it is the body of the sun in which the power to move the planets resides. So he says the sun must be a spinning body. I should have tried to look on YouTube or something like that. You can get a cabbage or a basketball, you can just get it wet and spin it. And water does not shoot off in like all directions spherically. It really concentrates in a disc coming off. So you can imagine like, whoa, the sun spinning this way, and it would move the planets in this disc type way. That's why, the planets aren't too weird. They're all kind of generally in the same area. But that only explains motion this way. He didn't really see how that explained motion this way. So he says that there must be some power also residing in the planet. And if someone wants to call that mind, I'd be cool with that. But I think that's, well, I don't want to say that. So that's, the type of communication LaRouche is saying we've got to make a breakthrough on, because the sun does not have vocal cords, but it does have coronal mass ejections. So we better start speaking its language. Or the whole galaxy. Because if the galaxy intends on a new extinction cycle, I'd rather be on the upshift side of it rather than the extinction side of it. So that's what I was thinking.
That is in human beings is what's organizing the solar system. His ability to figure out what's going on in the solar system is because it's governed by mind in the same way that we are governed by mind.
because, well, there's no other way to do it except through mind. Because the thing, like Kepler, when he discovered Earth's orbit and these ellipses and what Mars is doing, never really having ever left Europe, but he mentally placed himself on the sun, he placed himself on Mars, and just did all these thought experiments. Einstein did the same thing, Kuza did the same thing, that their thought experiments were, Einstein obviously never went the speed of light, but he could imagine what would happen if you did, or if you almost did. That's it. So, yeah, Kepler just shows over and over and over again how you use your imagination and the mind to just get beyond, what your senses seem to be telling you is true. Yeah.
One aspect, like this question of why the sun itself, you take the inverse, which is what kind of world would it be arbitrary? That it really didn't matter that everything worked just as well with that seven-sided polygons as they did with sixes or fives. And clearly everything doesn't seem to line up as well in Kepler's. His basic hypothesis is that the creator of the universe is not cruel. Is cruel, yeah, because it would be cruel, right, to make things arbitrary, that then you would have no way of knowing anything. And nothing would matter, and then you would be your existence. Because one of the questions always asked by scientists, why this way and not otherwise?
That's actually what Einstein says, that quote, subtle is the Lord. It's from, it's the title of the book, but it's him saying subtle is the Lord, but addicted is not. That to figure out the secrets of the universe, you've got to be keen. But they're there to be operated by man. They're there to be cruel.
Yeah.
I remember way back when I was doing my Kepler study, I built the model of political orbits nested in metallic solids.
Yeah.
So where do you fit that in with other things you're talking about?
Well, that was, definitely one of Kepler's first hypotheses of the ordering principle. That, which itself is pretty bold, given the dominance of Aristotle and Aristotelian thinking, that what goes on here on Earth is evil and bad and constantly changing, and what's going on out there in the heavens is perfect and sublime and unreachable by man. But then Kepler takes the geometry that works here on Earth, right, that human beings discovered a long time ago, and then just applies it to outer space. This tool of geometry, of learning proportions and all that kind of stuff, is a tool for man to discover that which we, through our senses, or in a literal way, would never be able to measure. And it wasn't totally wrong. He never really abandons that hypothesis also by the time, because that's something he really works through in the Mysterium Cosmographicum, when he just like a kind of a poor student, maybe he was just starting his teaching profession, but he didn't even really have a telescope, he had crappy instruments, it wasn't even good observations that he had, but the idea that you could know the construction of God's universe, is just a very powerful, motivating idea. And so we used geometry, and it was very close, but later which is why he goes to Tycho Brahe. He wants better observations, but it's kind of funny because he also had Cusa, who in the second book of Unlearned Ignorance makes it very clear that orbits cannot be circles, that God is perfect, something like perfect equality would exist in God. A circle, right, is all points along the circle are perfectly equal from the center of the circle. So a perfect circle in the real world, in the created universe, could not be possible. So all these guys are saying that the planets are circles, and you have the center, and you have the equant point. But Cusa had already, through principle, demonstrated that that could not be in the real created universe. The most perfect creation could not be that perfect. Philo has this idea also that, of just the constant changing. Anyway, so Kepler already had, because of Cusa, an idea of that the orbits can't be perfect circle. A perfect circle cannot exist. So in that sense, the nested solids would not exist exactly. But anyway, so he goes on, he does more work. He obviously discovers that there are ellipses, the musical ratios, and then in the harmonies, he said that the nested solids was God's first idea of ordering, but then he had to add the music to make it beautiful. Yeah.
Your faculty of sound more approximates the process of the harmonies of the solar system, though it's missing something. And there's something that the Platonic hypothesis from the domain of vision captures, but you're still missing something. And even these two things, you're still missing something because, the sun is communicating with the other planets. I mean, you and I were talking about this the other day. We take in solar radiation for all sorts of different things. Things are regulated by night versus day, you have photosynthesis, all these things. So the sun is communicating in all these different realms of the electromagnetic spectrum, visible, audible, all these different things. And so it's not like he had a hypothesis and then the second one was better or something in and of itself. It's just that it's something we're never really going to know in its totality the way the sun is in a dialogue with everything. So there's two ways, and one is a more perfect way, but it's still not the way. So the less perfect way is still useful. Even though it's of a lower domain, it's still useful in looking at the relationship. Because it's sort of the same idea, the equant, right? There's something interesting about the equant because this place of, uniform motion is a shadow of a place you would eventually go, of a higher domain of equal area, equal time, which is the sun. But that lesser domain, which he was investigating by moving the circle around, in a certain sense, it kind of exists, it kind of doesn't, but you have that same kind of phenomena. You move to something that's more accurate and more truthful and away from the thing that isn't, and you get the ellipses. But I think that that's an important thing to really remember. It's not like one hypothesis with the sound is better than the sight or something like that. It's just of a different domain. Yeah. Just like you can't say, like you could say, okay, well, the noosphere is better than the biosphere, but it doesn't mean that we don't need animals or bacteria or any of these things, even though it's of a lesser order. It's not like God made a bad hypothesis that's like, you should throw it out and only have humans or something. We get a lot of 7 days too.
Yeah.
It is kind of
Puppies.
nice, like the idea Mars though, because we do kind of get to choose the bad hypotheses. Like we're not going to bring cockroaches with us.
Yeah, hopefully. Especially the flying ones, really.
Yeah. Right. But you might want to bring puppies. Yeah. No, we definitely need those. Because they'll warn us about earthquakes on Mars. Yeah.
Why is the circle considered perfection and the ellipse is not considered a form of perfection? It's a perfect ellipse. It could have gone like that.
Because it's always changing.
Because
It's always changing. So it must not be perfect. Look, Aristotle is just insane.
It didn't obey a mathematical formula in Kepler discovery, though. Yeah, that's true. He had no idea how to calculate that thing.
So you can, based on your observations of the body, you can calculate what the future path of the body will be. And the gravitational fields are affected by the axis of the bodies in relation to, how they'll move. If they, so you run out essentially a course line that the planet or the body will take in the future based upon your past observations. If you were on that body, let's say you wanted to go from one position on the planet to another, the calculations you basically would use would be the same spherical calculations you would use on the oceans of this planet to go from one place to the other, where you don't have, let's say, established landmarks or fixed system of items that you go by. People normally navigate in their daily life by, the Empire State Building's here, this is there, and that's how they go. But in the middle of the ocean, you don't have that. So what you have to do is you work out your equations based upon your grid that you put on the planet. The grid would be the same here, on this body, and based on those observations, you know how to get around the planet. And then where the planet is going, or when it'll be in a particular position, regardless of how it's orbiting, will be based on your previous observations.
Right,
In other words, you go backwards.
There's two aspects to what you're saying.
You run your calculations backwards. You could also run them forward.
Right, but there's sort of a fallacy in what you're saying. Because on the one hand, there is a practical side in the real world, like when you're constructing something, you might have to measure, or you might do something, but you know that actually you'll never have a perfectly straight line. You'll never have a perfect. There's always going to be a teensy bit of error in the physical domain. And there's two questions. One is these questions of moving yourself through the universe, where you do have to do very complex calculations and so on. But the problem, what Kepler was looking at and what Lynn is looking at, is the question of the ordering principle of the whole. Because in reality, it's not a bunch of bodies in space. In reality, what's clear somehow is you have an ordering principle of the thing as a whole, which is also why if something is just the slightest bit knocked off, the entire thing changes. And you don't know how that would be. So it's not that each planet specifically has its relationship to the sun, because the universe would never work that way.
Well, if you can calculate, and they do now, because this is how they make almanacs. Okay, your nautical almanac in ephemeris is based on running up your calculations of the sun's transit through the galaxy. And they do these calculations as a matter of routine. So they're making up a nautical almanac for about 3 or 4 years from now, in which they're figuring what the position of a body will be in relation to
Right,
our
but what are
planet,
you
and
moving
your
in
planet's
space?
position
What are you
related to
moving in
that.
space? You're
You
moving
understand?
you're moving a human being.
What?
You're moving a human being. A human being is going to Mars. Because here's the thing, it's not just, okay, you're going to space and all of a sudden everything's moving, and how do you sort of maneuver through the maneuvering, right? Because you could do that in water. You could just throw a bunch of things in the water, different speed boats. I mean, I'm sure you've been to a lake and seen the remote control boats. Like, you can figure out how to do that. But the real issue is the human being is going to be subjected to an experience never before experienced. It's a different space-time. So it's not just that you're going into space and you're dealing with motion, you're dealing with the total transformation. What's the effect on the universe of a ship going at 32 feet per second squared at an accelerated rate and then decelerated rate to Mars? But it's an actual different space-time, so it's not even the thing, how it's going to get there, but what's the transformation inside of that thing? And it's a totally higher domain of mathematics.
Put this ship
Of
in
everything.
perspective. What's the effect of an ant pushing something across the surface of the ground towards an anthill? You know,
But you're not an
No,
ant.
it's totally not the.
you know,
An ant is not going to fly a spaceship to Mars. We're talking about a mathematics for human beings, for the human mind, and how it relates to a universe that's changing and that
the
it
only
will
the
change.
thing that changes our perception.
That's not totally true.
With constant learning process.
That's not totally true.
you know.
No, because we don't, suppose you could figure out how to travel at the speed of light.
But
What if you figured out how to travel at the speed of light? And what's going on that we're observing some things out of the Crab Nebula which seem to imply motion faster than the speed of light, which according to what Einstein was working on isn't possible, which means that space itself may not be shaped in a Euclidean way. Like it actually may not be the case. It looks like I would go from here to Stephanie and that would be fairly direct.
well,
But that might not be true.
if you're talking about one sense of spaceship from here to there, let's say the Crab Nebula, you're going to have to make a calculation of the movement of the galaxy and where that Crab Nebula is today. If you're going to go at a certain speed, you're going to have to go in excess of the speed of light.
Well, I'd
You want
say
to get
what-
there, and that's a whole
to
different
send a
bag.
space
Right,
shuttle
right.
somewhere where we're actually gonna have to make not equations, but a political revolution. That's how they would do that.
But see, what you're saying, I get what you're saying, but here's the thing. You could say, okay, well, I want to go to the Crab Nebula, or I want to go to the star. Therefore, I'm going to see, okay, where is it going to be, however long it takes me to get there, blah, blah, blah. You can figure all that stuff out, fine. However, what time is the person in that spaceship going to experience? How old are they going to be? How are they going to change? Because what you're looking at is you're looking at different rates of change and different rates of development. It's much bigger than just looking at the future and seeing how things are going to change in the future, because you're transforming the future and you're being transformed, and what you're looking at are processes of change in different domains: living, non-living, noetic, created from the universe, created by man. You're looking at these rates of change that are phenomenal, and it's just a little bit more complicated than thinking, it's going to take me a week to get to Mars. Where is Mars going to be in a week?
With the equipment that we have now, we can adequately run up calculations to figure where our body's going to be. That's how we're able to land on the moon.
Yeah, we'll still probably miss it though, if we only rely on that. If we go to Mars and we only rely on that. Once we start getting this 1G acceleration. That's why LaRouche is a freaking genius, because it's going to take a higher domain, it's going to take a higher language, and this is why she's giving a class on metaphor. Because the mathematics that we have right now isn't adequate.
Right.